Hello friends, today we will explain about three laws of Newton.
Why is it important to learn the three laws of motion? To understand that, we should know first about Newton itself. So, who is Newton? Isaac Newton was born on January 4, 1643 in United Kingdom. He was a mathematician, physicist, astronomer, theologian, and an author. His well-known discovery is the laws of motion and the law of universal gravitation. He is important because he developed the theory of gravity, laws of motion, which is the basis of physics, calculus, and made breakthrough in the area of optics. He inspired many scientists to become like him, and without him, many mathematicians and physics law would not exist, including the gravity, motion, optics, and light. His discovery has changed the whole world to a greater knowledge. In this section, we will discuss about Newton's first law, Newton's second law, Newton's third law, and the exercises.
Newton's first law states that every object remains in a state of rest or of uniform motion in a straight line unless forces act on it to change that state, so the total force is equal to zero. Newton's first law of motion, also called law of inertia, in simple words we can know that the object continue to do what they are doing unless some external unbalanced force acts on them. So there's two balls. The first ball is not moving, so the ball will continue not moving unless there's unbalanced force. The second ball is moving, so the ball will continue moving with 3 meters per second unless there's unbalanced force. So we can know that moving objects do not change their route or direction unless any force causes them to move from their path. If the forces are balanced, there can be two cases, an object at rest or object in uniform motion at non-zero constant velocity in a particular direction. When objects are at rest, the object will continue to remain at rest, while object in uniform motion will continue to stay in motion at the same velocity and same direction.
Next, we will talk about Newton's second law. So, it stated that when a force of F Newton acts on an object of mass m kg, it produces acceleration a meter per second square given by force is equal to mass times acceleration. So what does it mean? Now let's suppose that you are driving a car with your friend. Then suddenly, your car runs out of petrol and you can see that the filling station is near your location. Then, you decided to push the car together with your friend. At first, the car will be stationary. After that, the push will give the car a velocity, so the car accelerates. In this case, the car will accelerate to the same direction as the force. However, in here, if you have to push a minibus and a truck with the same acceleration, then it takes much more force to push the truck. Why? Because the mass of the truck and minibus are different, as the truck is much more heavier. So that's why in Newton's second law, the force acting on an object is proportional to the product of its mass and the acceleration produced.
Newton's third law states that if a body A exerts a force on body B, then body B will exert an equal and opposite force on body A. The formula of Newton's third law is force of body A equals to force of body 2. Since force equals to mass times acceleration, we could derive the formula to mass times acceleration of body 1 equals to mass of acceleration of body 2. Imagine yourself you stand on a roller skate facing a wall. You push on the wall and you move away from it. This is because you exerted a force on the wall, and in turn, the wall exerted an equal and opposite force on you, making you move away. The second example is, when you step on a bathroom scale, the scale exerts an upward force on you, and so you exert a downward force on the scale, and therefore it shows your real weight. Newton's third law had many real-life examples that occur every day in our daily life. The examples of Newton's third law can be seen in rockets flying upwards, jumping off a trampoline, walking forward, and the force of attraction between book and earth. This example can be seen in the picture above, where there is every action and reaction.
Now, let us go to the exercise part. Question 1. If a ball is traveling at a constant speed of 10 meters per second, what is the resultant force of the ball? First, to answer this question, we need to take the keyword constant speed. At a constant speed, there is no acceleration. Due to that, the force is equals to 0. Now, let us start with question number 2. A man pushes a box which has a mass of 20 kg with a force of 500 Newton. The ball experiences a resistive force of 100 Newton. What is the acceleration of the box? Now, we must find the resultant force. The resultant force is equal to 500 minus 100 Newton, which is equal to 400 Newton. Remember, force is a vector unit. Force is equal to mass times acceleration. This is Newton's second law. Now we plug in the number 400 newtons, which is the resultant force, equals to the mass of the box, which is 20 kilograms, and the acceleration. From here, we can derive the acceleration to 20 meters per second square. Now, we can start with question number 3. A car with a mass of 1,500 kilograms tows a trailer with a mass of 500 kilograms. Assuming that there is no resistive force experienced, what is the driving force of the car when the trailer and the truck is accelerating at 0.5 meters per second square by showing Newton's third law? Now, we can see that there is a force of C2 and C, which is equal in magnitude but opposite in direction. This proves the Newton's third law, because there is an action by the car to pull the trailer, but there a reaction back to by the trailer, which is force C2 to the car. So now let us focus on the forces that are experienced by the trailer, which is force C. C equals to mass of trailer times acceleration. Hence C equals to 500 times 0.5 meter per second, which equals to 250 Newton. Due to Newton's third law, C and C2 is equal in magnitude but opposite in direction. Hence, now we can find the driving force by using driving force minus C2, which is the resultant force, equal to the mass of the car times acceleration. Driving force minus 250 Newton, which we got before, equals to 1,500 times 0.5. Hence, we get a driving force of 1,000 Newton. That's all from us. Thank you, friends, for watching our video.